All right, what do we got to do first for the warm-up problem? Bring 4 to the other side, good. So we got 3x squared plus 11x minus 4 equals 0. So that's always the first step when you're solving by factoring a quadratic equation. Set it equal to 0. Now, is there a GCF? Always look for that first when you factor. No. So it's got 3 terms. It's one of those trinomials. Are these both positive perfect squares? No. So it's not one of those special trinomials. Okay? So multiply 3 times negative 4, what do you get? Negative 12. Right? So here's all the possible factors of negative 12. All right? Then you add all those. So that's 11. That's negative 11. This is 4. That's negative 4. This is 1. That's negative 1. Which pair do I want? The first one, right? Because I got a positive 11 when I added them, and that's my b value. Okay? So I have to rewrite the 11x as negative 1x plus 12x. So I turn it into a grouping problem. So we group first 2, last 2. And take out GCF. What's the GCF of the first group? X. What's the GCF of the second group? 4. What's 3x squared divided by x? 3x. What's negative 1x divided by x? 12x divided by 4. Negative 1 or negative 4 divided by 4. Negative 1. All right. My 2 binomials in the blue there, are they the same? Yeah. So that's one of my factors. And then the GCFs I pulled out is the other factor. Are we finished? No. All right. You did everything right so far, and then some of you stopped. Okay. We're looking for what x equals to make this equation equal to 0. So x plus 4 equals 0. So one of my solutions, one of my roots is negative 4. 3x minus 1 could be 0. One of these two has to be equal to 0 for this to be a true statement. So we have to set them both equal to 0 to solve for x. So my other answer is 1/3. Sometimes you're going to get fractions or decimals. It's okay. Questions? Okay. Looking at the homework that I showed you, checking your work, any of the first 3 you want to look at. Maybe number 2. I like my x squared to be positive, so I'm going to add x squared and 12. Actually, yeah, I'm going to add x squared and 12. So I get x squared plus 25 equals 0. Okay? That could be a typo. Maybe it was supposed to be 12x, but the x isn't there, so we'll just do it like this. All right? Graphing, we said to use our calculator, right? All right, so I go to my y equals and put x squared plus 25, hit enter. And when I do it graphically with my calculator, what am I looking for the answers? Yeah, where the thing hits the thing. What are we talking about? What thing?
Where the line crosses over the X.
The x-axis, yeah. Where our parabola crosses the x-axis. Okay? So when I hit graph, watch to see where the parabola crosses the x-axis. Did it? No. So if we're doing it graphically, what's our answer? No solution. Okay? Now, we're going to talk about that solution, how we can get that solution another way. All right? Today. But and graphically, we can't get it. All right? So, we good for the first three? Again, now's the time to ask questions if you're not sure about something. All right, the next three said square roots. All right, you got to get the squared part alone. Okay, the one that probably gave you the most issues is this one over here. First step, get the p squareds together on the same side. So what's 1/7 minus 5/7? Negative 4/7. Is the squared part alone yet? Is it isolated? No. So we got to move the negative 4/7 over. Okay? This means negative 4/7 times p squared. So if I'm multiplying something and I want to move it over, I should divide. But what do we do when we divide by a fraction? Multiply by the reciprocal. That's easier, right? Okay? The 4's cancel, the 7's cancel, two negatives make it a positive. So it's just p squared. That's what I want, right? When I multiply negative 20 times negative 7/4, I can take the 4 into 4 and the 4 into the 20. So what's a negative 5 times a negative 7? All right, it's a positive 35, right? Or if you want, you can go 20 times 7, 140 divided by 4, you'll still get 35. Okay? Now, what do we do to both sides? Square root. Remember, when we do this step, you have to put that symbol in front of your answer. Okay? Plus or minus. And then if the square root of 35 does not simplify, so you just leave it as the square root of 35. Okay? The rest is factoring. All right? Get them equal to 0. Any of those three you want me to go through? And this says when it finds the zeros, it means the same thing. All right? I would just factor if it's factorable. If it's not factorable, then try to graph it. All right? But all those were factorable. Okay? Any of those? Hopefully you understood how I did them when we looked at them. All right? We're good? All right. So I talked about this the other day really briefly because we had a problem in one of our examples that we were taking the square root of a negative number. All right? So we talked about the imaginary unit. I think that was, might have been Monday or Tuesday. All right? So it says not all quadratic equations have real number solutions. For example, x squared equals negative 3 has no real number solutions because the square of any real number is never a negative number. To overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I. So I is the square root of negative 1. Which means I squared equals negative 1. Okay? So you're gonna get some problems today where you're gonna end up with an I squared. What are you gonna change it to? You're gonna change it to a -1. Okay? Whenever you see I squared, like if I had 3I squared, that's actually 3 times -1, which is -3. Okay? So we're gonna run into that a little bit today. All right? So whenever we see a negative sign under the radical sign, we're gonna pull that I out and then simplify the radical like we've been doing. Okay? So this problem here, this example they did, whatever's in the parentheses, they raised to the second power. So the I got raised to the second power. And what's the square root of 3 squared? Itself, right? 3. So that's where that 3 came from. Well, since we have an I squared in our problem, that's actually -1 times 3, or -3. Okay? So we're going to look at some examples with some negatives under the radical sign. All right? So 25 is what type of number? Perfect square, right? So what's square 25, Mason? 5. Since it's negative, we're going to make it 5I. All right? Whenever you see that negative sign, I is part of your answer. Okay? We good with that one? All right. AJ, factor tree. What would you use? Two and 36? Don't worry about the negative. What are we going to do because it's negative? Pull the I out, right? So I would stop there and circle that because what is 36? Perfect square, right? So what number can I pull out? 6. So I'm pulling the 6 out and the I because it was negative. And then the 2's left under the radical sign. Okay? So it's just like we did with radicals on Monday, except we have that negative now. So I is part of our answer when we simplify it with our factor tree. Question? Sophia, what do you think? Right. So what's the answer? What's the final answer? -15I. All right? Since that was -5, that means times the square root of -9. Well, the square root of -9 is 3I. So then I multiply those together, so it's -15I. Okay, another perfect square there. Okay, I guess there's no D, all right? Questions on the first 3 examples? Make sense? Not too bad, is it? Okay. How about that one? Nick? Is that what you're going to say? Yeah, 81 is a perfect square, right? Collins, what's the next one? Eight and 7, okay. Any perfect squares, either one of those? All right, can I break 8 down?
Yeah. 4 and 2.
Okay, any perfect squares there showing?
Yeah.
Yeah.
I know Berkey.
Keep going. Caleb, Berkey.
Yes.
Caleb Collins, finish.
We're gonna have 2 on the outside. Yeah. This is why you need my help.
Don't help him, Caleb. He can figure it out. What about the negative?
I can't think of it.
Cole, help him out.
4i.
Well, because of this, what else is coming out front? The I. All right. So Caleb Collins, what's left underneath? Which is, yeah. Just multiply what's left. If there's more than one number left underneath, just multiply. If there was more than one number we could pull out front, we would multiply. Okay? Caitlin? How would you do factor tree for 12? Whoa. 4 and 3, that's what I would do too. Is there any perfect squares showing? Yeah. So what's our answer? You're not pulling 4 out, what are you pulling out? Yeah. Good. Right, so because of the 4, we pull the 2 out, times -7. That's where the -14 came from. Since it was a -12 under there, because of the negative, we pulled the I out. And there was just one number left, the 3. Okay? Good at those? I think so. All right, complex numbers. Right, they have an imaginary unit in them. Right? So a complex number written in standard form is a number a plus bi, where a and b are real numbers. The number a is the real part, and the number bi is the imaginary part. Okay? If b does not equal 0, then a plus bi is an imaginary number. If a equals 0 and b doesn't, then a plus bi is a pure imaginary number. The diagram shows how different types of complex numbers are related. So here's a complex numbers are a plus bi. If the b is 0, there's really no I. So these are just our normal real numbers we're used to working with in the green area. In the blue area, a plus bi, we got a is 2, b is 3, a is 9, b is -5. Those are a normal imaginary number. A pure imaginary number is when the a is 0, okay, and the b is not. So 0 plus or 0 minus 4i is actually -4i, and 0 plus 6i is 6i. All right, so the purple ones are, but the purple ones are part of the imaginary numbers because they're inside the blue area. Okay, so that's how they're related. So we're going to add and subtract these. Oh, before we do that, maybe it says it here at the bottom. Yeah. Two complex numbers, a plus bi and c plus di, are equal if and only if a equals c, those are equal, and b equals d. Those are equal. All right? So the real parts you set equal to each other. The b parts of the imaginary number you set equal to each other. So a problem like this, those are the real parts. So if these two imaginary numbers are equal, that means those two parts have to be equal. And those two parts have to be equal. So they just want you to solve for x and y when you do that. All right? So what do I got to do to solve for x? Divide by 2. Y is already by itself, so we didn't have to do anything there. So when you'll get a problem like that. So Connor, what am I going to set equal?
5x equals 180.
And 4 and what? What's in front of y? Yeah, 2y. Yeah, so the parts, the real parts set equal, and then the imaginary parts set equal. All right, so I'm going to divide by 2 to get y by itself, and I'm going to divide by 5 to get x by itself. So they're easy equations to solve. You just got to put the right parts together. Those make sense to you? Any questions on those?
Yes. Why is the I the other way?
Because, if you put 4i equals 2yi, all right, and you wanted to get rid of the I to the other side, what's going to happen to them? They're going to end up going away anyway. So we just don't even worry about them. Good question. Anything else? Okay. So, sums and differences of complex numbers. Just treat them like terms. All right? The parts that are i's with them, the imaginary parts, you can add and subtract. The real parts, you add and subtract, because they're like terms. Okay? So, the A and the C are the real parts, I can add those. The BI and the DI are the imaginary parts, I can add those. Same with subtraction. I can subtract the real parts, I can subtract the imaginary parts. Okay, just treat the i's like it was an X or a Y, or an A or a B. All right? So what's 8 plus 5? Somebody? 13. What's negative I plus 4i? 3i. That's all. Don't overthink it. Okay, William? AJ, what's this one? Minus the. Right. Yeah, 0i, right? You can write the 0i or you don't have to. You can just put 4. Doesn't matter to me. But the minus a negative makes you do what with those 6s? Add, right? It's like negative 6 plus 6, right? All right. What do you think you do here, Tristan?
Distribute.
Yeah, you just distribute like you normally would. All right? So what's it equal? Go ahead, Tristan.
Okay. We get negative 20i.
Well, it's a 6, not a 5.
I. And 4i squared.
Right. Just like x times x, you get x squared. I times I is I squared. Is that it? Finished? Done? No. Why? What have we learned today about this? It equals negative 1, right? So here's what I do, is I cross this out and just change the sign, because 4 times negative 1 is negative 4. Now, the proper way to write this would be the real part in front and the imaginary part in back. All right, that's how it should be written. If you write it as negative 24i minus 4, I'm not gonna count it off, but it really isn't the proper way to write it. Okay, so that I squared is showing up now. Questions on that example? Okay, Taylor, what do you think we should do here? Is there addition sign between them? Okay, so I can't just go 9 plus -4. Yeah, so what do we do when we have two binomials and we multiply? What do we call it? Yeah, we're foiling it. Right? Okay, Taylor, go ahead.
9 times -4 is -36. 9 times 7 is 64.
Good.
And then -2 times -4 is +8.
Good.
And then -2 times -7 is -6.
And then remember, it's I squared. That last one is I squared. Are we finished?
No.
No. Now, before you combine like terms, what should we do here?
Change that sign.
Yeah. Do that. All right, so Taylor, what's the final answer? Well, what's -36 plus 14? Nick? Good. What's 63i plus 8i? 71i. Do we understand that?
Yeah.
Is that difficult?
No.
No, pretty easy, isn't it?
Yeah.
You guys know how to distribute. You know how to foil. Just treat the i's like any other variable. Just remember, when an I squared pops up, that was like -14 times -1. That's why we made it +14. And then combine like terms. Okay? What's first? Anybody? 44. Outside, 32i. Inside, if it was 11, it's 21. What's another 11 on 121? 132, good, Nick. What's -12i times 8i? Yeah, -96i squared. Okay, so what happens to our 96? Becomes plus 96, right? So combining like terms, 96 plus 44, 140, and 32 minus 132, minus 100i. Okay? So adding and subtracting, you combine like terms. Multiplying, you got to FOIL. All right? There you go. Good job today. Yeah, shouldn't take you long, because it's not bad.